Hey, good afternoon. So basically, we're going to talk about a third form of quadratic. So we've talked about vertex form, which depends on the vertex, factored form, which depends on the x-intercepts, and there's one more, and it's known as standard form. So that form looks like this. All right, the problem with this one is it's not necessarily one you can immediately get from a graph. It does contain the a value, which we already know can stretch, can shrink, or can flip. This c value actually ends up being the y-intercept. The problem is that b doesn't represent anything on the graph, which is the problem. So we, once again, can't really figure out this equation from the graph itself. We'll see that the y-intercept matches up. We'll see a stretch factor, but that's about all we can see. Turns out that this format is actually really useful for applications. We'll get there eventually, but right now, all I need you to know is that if we know the factored form, we can actually find standard form from that. And the key to understanding that is really understanding. So here's my first example. When I'm writing 2x plus 4 in parentheses, x plus 6 in parentheses, it's really important to recognize that all of these things are being written next to each other because they're all being multiplied. And so all I'm going to do is kind of go through and actually do that multiplication. So 2 times x and 2 times 4. It's really going to be 2x plus 8. But I'm going to keep that in parentheses because I still haven't dealt with multiplying by this x plus 6. And it turns out that this operates under the idea that everything here needs to be multiplied by everything in here. In other words, I need to do 2x times x. So the key here is x times x is really x to the second power. And then I have to do 2x times 6, which will be plus 12x. So I've multiplied the first term by both things in the other set of parentheses. Now I got to do the same thing, but with the second term. So I got to do what's 8 times x? 8x. And then finally, what's 8 times 6? Turns out 48. So now I have all of this. In case you aren't aware, if an exponent is attached to a variable, it is not a like term to other exponents to other variables without an exponent. So in other words, 2x squared is its own thing because there aren't any x squareds around. But you'll notice there's a plus 12x and a plus 8x. And so these two things can actually be simplified to a plus 20x. And so that means in standard form, that is my equation. So once again, I had to deal with first multiplying the 2 inside. And then from there, I had to do first term times both things in the other set of parentheses, and second term times both things in parentheses. And then I saw I have 2 x terms without exponents, and so I can combine them into a single like term, and there I have it. And just to confirm that what I've found is actually true, if I type in y equals 2x to the second plus 20x plus 48, sure enough, I get the exact same parabola as the original. And so now I know I'm good to move on. All right, so we'll take a look at another example here. And I wanted to throw in some negatives just to make sure that we're okay with those properties. So example 2 here, it's the same exact thing. So once again, this really means -3 times x minus 5 times x plus 2. So if I multiply in the negative 3, I'm going to get negative 3x. Negative 3 times negative 5 is going to be positive 15. Be careful there. And then I still have to multiply by x plus 2. So I'll just do negative 3 times x. So once again, x times x is going to be x to the second power. And then I have to do negative 3x times 2, which will be negative 6x. Then I got to do 15 times x, which will be 15x. And then finally, I have to do 15 times 2, which will be 30. Once again, x squared, there's no other x squared, so that term can't change. But I have a negative 6x and a plus 15x. So these are my like terms. And so if I combine those, I will get a positive 9x. And so that is a 0. In standard form, this would be my equation. And let's do a quick graph verification again. So y equals negative 3x to the second power plus 9x plus 30. And sure enough, it's a very tall one. They end up graphing right on top of each other. So once again, I know I'm good to go. All right. So this brings up kind of one last point I want to make. I'm going to bring up 3 points. And so here are my 3 points. What I want to do is I want to create an equation in all 3 formats. So the first thing you'll notice, or the first thing I hope you notice, is that I have 2 x-intercepts, negative 6 and 3, 0. So when I'm thinking about this one, I know that if I were to put it in standard form, in factored form, I'm going to have, and remember I'm just going to start with a as 1, I'm going to have x minus negative 6 times x minus 3. All right, so far so good. I've got a parabola that goes through both x-intercepts. And now I'm just going to play with the a value, see if I can find the proper a value. So clearly it needs to stretch more because it's not catching this point here. And if I make it a 2, now sure enough, I've got a parabola that goes through all 3 points. All right, so in the first case here, I'm going to write it piece by piece. So that parabola that I just had in factored form, we just said it's y equals 2 times x minus negative 6 times x minus 3. And I could totally notice the double negative. I can clean this up a little bit by making it an x plus 6. Great. Now, like I said, I want it in all 3 formats. But since I already have factored form, I might as well say, well, what's standard form going to be? Well, in other words, what is 2 times x plus 6 times x minus 3? 2 times x, 2 times 6. This is going to be 2x plus 12 times x minus 3. So 2x times x will be 2x to the second minus 6x plus 12x minus 36. And once again, 2 like terms. So I'll have 2x squared, negative 6x plus 12x is positive 6x. And now I have standard form. All right. And then finally, my third format is vertex form. And so going back to the graph, notice how when I graphed it, actually, let me prove that standard form works. All right. Once I graphed it, notice how it actually shows me what my vertex is. So before, when I didn't know what the parabola looked like, I just knew the x-intercepts. All I could do was create the factored form. But then once I knew factored form, I could quickly find standard form. But now the question is, what about vertex form? And if we look right here, we can see the vertex is at negative 1.5, negative 40.5. And so we already know the a value is 2, so x minus negative 1.5 to the second power plus negative 40.5. Now, all of a sudden, I have my third version of the equation because, once again, by graphing the curve, it revealed to me what the vertex was, and then I could quickly find the vertex format. And notice how the a value in all three formats is exactly the same as it should be. So once again, to find factored form, you need to know the x-intercepts, which we did. Once we knew factored form, we could then find standard form. And then finally, once I had a graph of the parabola, I could finally see what the vertex was, and so I was able to write it in vertex form. And that's it. So when you're doing today's assignment, the first few problems are going to be, can you just convert from factored to standard? The last two problems are going to require that you find all three formats for two different parabolas. So I think you have the tools, but if you have not done Monday or Tuesday's assignment, make sure you've taken a look and understand that before you attempt today's. Please reach out if you have any questions.